Hello everyone, I'm Atai from the FLL team RoboRoos East. Welcome back to the second episode of our series. Today we'll be going through the gyro and how to turn to an angle using it. The gyro is an excellent piece of equipment that tells the robot what angle it is currently facing, but it does have some limitations. One that you'll become accustomed to is drift. Drift is when the gyro thinks that it's still turning or changing angle, even if the robot stays perfectly still. Some ways to avoid drift is to make sure the robot is still when turning it on, and you don't use any rapid movements of the robot. Both of these can easily cause drift. The most common way to remove drift, which is what most people use, is to unplug it and plug it back in again. This can be difficult because if the gyro moves at all during this process, the drift will continue. So we have made a short program that helps to deal with this, but it isn't usable in every circumstance. Okay, so before we begin, what you'll have to do is you'll have to go to your browser and go to the download section of the LEGO Mindstorms website, and you have to download what's called the gyro sensor block. If you've already done this, you can skip this. And so you'll click on it and it'll download the content. So you'd press OK. And then you go to your Mindstorms and go to Tools and select Block Import. So then you'd hit Browse, Downloads, and you'd select the block to import, in this case gyro, and you'd hit Import. And so then it'll come up with this sign saying you must restart the EV3 editor. And so you'll hit OK, close, and just restart. This block that we have made has 3 stages. The first is to do a regular gyro reset. The second is to measure the angle that it's changing. And the third is to measure the speed that it's turning at, so the rate. But we do all these separately, so what you want to do is you want to put a 0.3 second wait between these, as well as at the end. What this does is it helps the gyro to update and make sure that everything is at the value it should be. This does, however, take time, and it should be used sparingly if used for FLL. We recommend running it at the beginning of your program and using a regular reset anywhere else. So from here you do the same thing as before. You select this and go to Tools, My Block Builder, and we use this icon and name it Gyro Reset. But there's no need for any inputs or outputs, and you just hit finish when you're done. Now before we continue, we have to talk a little bit more about the gyro, because there's another major problem with it in the case of our program, and it's that the gyro doesn't reset back to 0 if it goes over 360 degrees. This means that if you try to turn over a full circle, the number that you are given will continue to climb instead of going back to a number that is simple to use. To solve this, we use a mathematical formula known as modular. So modular is done with a % sign, and essentially what it means is that it will give you the remainder when you divide by a number. For example, saying 10 modulo 2, just like that, will give you 0. As when you divide 10 by 2, you get a remainder of 0. If we said 11 modulo 2 instead, you would get an answer of 1, for the same reason. Similarly, to fix the problem with the gyro, we get the current gyro reading and modulo by 360. So in this case, we'd do something along the lines of A modulo 360. We'd then create a gyro read block and plug it into the A section. And so what this does is if the number goes over 360, it'll just reset back to 0 and start all over again. Okay, so now we'll be making a block called turn to, and essentially what it does is it turns to an angle that we give it at a speed and with an accuracy that we give it. So essentially it just turns towards an angle. What we've done is created a my block called turn calculation. It has an input of the angle that we want it to reach. Inside of it we have just 2 blocks. The gyro sensor read block and an advanced maths block. So take the gyro sensor wire and plug it into port B, and then type in the following formula. So A minus B plus 18,180, then modular, or you can use the percent sign, 360 and minus 180. So what this will do is it takes the wanted direction, which we'll plug in later as A, and the current gyro reading, and get the difference. Then add 18,000. And what this does, it'll let us do 50 turns before the math stops working, as modulo doesn't work on negative numbers. So we add this number to make sure it's always positive. The next problem is that if we simply modulo by 360, we'll always get a number between 0 and 360. But what we really want is a number between 180 and minus 180, so that the robot turns the shortest amount to get to the right angle. So what we do is we add 180 before the modulo and take away 180 after the modulo, so that we get a number in between that range of values. So the number we get at the end of this block will be how far we still have to turn until we get to the current position. From here, we can make it a my block with one input and one output, going to Tools, My Block Builder, and adding an input and an output. We use a math sign for this as the icon, and so the input should be wanted direction, and the output should be turn angle, and the way you change into an output is just click the parameter type and set it to output. And what you can do is you can give the parameters icons. So what we're going to do is we're going to give it a quarter circle for the input and an arrow or curved arrow for the output. Then all you have to do is give it a name. So in this case you'd make it turn calculation, and you hit finish. Okay, so now that you've got this screen, all that you have to do is take the wanted direction input and plug it into A, and then take the output from the maths block and plug it into the output section. The solution to the maths block will be here, and so we can use this anywhere. So, for example, we can put this into a display, and that will show us however far we are from 0. So if we're at negative 70, then the number we should be seeing is negative 70. Okay, so now we can get to our first movement block. So first you have to put in a loop and the turn calculation block we just made. And you also have to add in a compare block that checks if turn calculation is greater than 0. So what this does is it takes the amount we still have to turn and checks if it's less or greater than 0. Basically, it's testing for which side we should turn to move the shortest amount. So now you have to create another maths block and change it to absolute value. And what this does is it changes whatever number you give it into a positive number. And so essentially if you give it a negative number, it'll be positive. But if it's already positive, it'll just stay as positive. Okay, so now what you have to do is you have to take a switch and make it tabbed view and change it to logic and plug the compare block in. And then in the true state, what you want to do is you want to just set it to on, and you want to and what you can do now is you can change this to 100 so it always turns the right way. Then you can copy it into the false. And now what you want to do is you want to put the absolute value for the speed and make sure the one in false has negative 100 for its balance. So what this does is it takes the angle away, so it has the true or false from the compare block. And if it's true, it'll turn clockwise. If it's false, it'll turn counterclockwise. And this just makes it turns to the nearest. And so what you have to do now is you have to get a maths block and set it to multiply by -1. And then you have to take what's called a range block and plug in the output from the multiplication block into the lower bound section of the range. Then what you have to do is you have to take the output from turn calculation and plug it into the test value. And what this will do is it checks if turn calculation is between a certain range of numbers. So in this case, if we want to do it 1, what we'd do is we'd set this to 1 through an input in the my block, and we'd also put the 1 in here, and it will check if it's between -1 and 1, just so that we can get 1 off from the wanted direction on either side. Okay, so now what you want to do is you want to set the loop to logic and plug the output from the range in there. And outside of the loop, you want to put a move steering block and select off. And so what this will do is once we are inside of the range, it'll exit the loop and it'll stop the robot from turning. Okay, so now that we've done this, you have to select everything you've made and go to Tools, My Block Builder, and you can give it whatever icon you want, but we use move steering. And then you want to add 3 inputs. The first input should be called wanted direction. The second input should be called speed. And the third input should be called accuracy. And so now what you want to do is you want to give them icons. So for wanted direction, we'll use the quarter circle from last time. For speed, we use this question mark thing. And for accuracy, we use these arrows. So now all you have to do is call the My Block Turn To and click Finish. Okay, so now you should get something that looks like this, and what you have to do is you have to take this wanted direction input and plug it into turn calculation. And you'll want to take the speed input and plug it into the absolute value block that we made. And then you want to take this accuracy and put it both in the multiplication block and in the upper bound of the range block. And so there's your turn to. So now you can use this basically whatever you want. So yeah, so you can say turn to an angle of 90 degrees at a speed of 30 with an accuracy of 1, and it'll turn to wherever you want. Now the other thing is, if you put it on too much speed, it does have some problems. So we suggest no more than a speed of 30, and keep an accuracy of about 1 or 2, and only use 2 if you are up near 30. So thank you for watching. Don't forget to like and subscribe if you want to see more content.